I hope all of you recall something about collision. Collision is something when the two objects exert force on each other. Two objects exert force on each other. This is pair forces. Forces are equal and opposite. If forces are equal and opposite, impulses are also equal and opposite. If impulses are equal, change in momentum also. So what is the collision? Is exchange of impulse, and it is equal and opposite. So the change in momentum also is equal and opposite. Hence, momentum of colliding objects as a system is conserved. So if we have two particles, they collide, other than internal forces between two particles, no other force is acting, the momentum of the colliding objects as a system is conserved. That's the only new thing about it. I think one more thing we'll add is the definition of coefficient of restitution. That completes more or less the theory part. The rest all is simple application of basically laws of mechanics and coefficient of restitution. To understand coefficient of restitution, let's first understand what does line of collision be. The line of collision, suppose when the object comes and strike here, and if the surface is smooth, line of collision in this case, what would be the line of collision be? Line of collision in such case, line of collision is along common normal. Why do we take along the common normal? When these two objects get in contact with each other, the contact force will act, and if the surfaces are smooth, most cases we take the surfaces to be smooth. If surface is smooth, contact force can act only along the normal. So this is the direction this surface will apply force on the object which is round shape, and there will be other one also will applying equal and opposite forces. So line of collision is along the common normal, and thus also the direction along which the internal forces will act. And suppose the objects are in this fashion, can we identify common normal in this case? If two spherical objects, one is both may not be of equal radius, like a kind of a billiards table, we see the ball is striking each other. When they get, what is the common normal here? So of course, I think you've done circles, you know. So if I join the centers, that would be the direction of common normal. And when these two objects collide, the force as well as impulse and force act in the same direction. If this is the center here and this is the center here, so common normal will be along this direction, and I will call this a line of collision also. Not line of, this is a line of collision. And it's pretty simple concept. I think it's easy to understand. What does it imply? For a smooth surface, impulse acts along the line of collision. And most cases will take a smooth surface. Few exceptional cases only we look at later on, not now. So what is head-on collision? Head-on collision is velocities along the same line as line of collision. In that case, what happens? Velocities and impulse are in the same direction. Entire motion becomes one-dimensional. So anything head-on collision, since the entire motion velocities, initial velocities in the particular direction, since impulse acts in the same direction or opposite direction, the line of motion does not change. The impulse doesn't have a perpendicular component. So entire motion remains in one dimension, and one dimension makes things easy. So even for vector also, we can take care of vector direction with plus and minus sign alone. So that makes things easy. Plus minus sign is enough. That's enough to deal with vector quantity. So we like head-on collision for that reason. And later on we'll see even oblique collision also we can deal with, similar to head-on collision. So we define something called coefficient of restitution. What is coefficient of restitution? It is of negative of velocity of separation, relative velocity of separation, divided by relative velocity of approach. The reason why we take negative sign, velocity of approach and velocity of separation are in the opposite direction. We'll come to that. So this is an important point. So if I have to look at velocity of separation, what is the magnitude of velocity of separation? This will be equal to E times relative velocity of approach. That's velocity of separation. Okay, and in most cases we deal with one dimension. Since we deal one dimension, it is either the sum of the velocities or difference in velocities. Okay, so types of collision. So this is elastic collision. We define type of collision. Mostly we can define collision in terms of E. Perfectly elastic collision. when object regains its original shape. When it regains its original shape, there's no loss of energy, and we take coefficient of restitution is equal to 1. Perfectly inelastic. So perfectly inelastic, it deforms and it doesn't regain its form at all, even not even partially. There's no reformation. Deformation is there, but there's no reformation. Objects stick together. Velocity of separation is 0, and E is also equal to 0. Velocity of separation 0 itself implies E is equal to 0. Thus, perfectly inelastic. In between, so E can range between 0 to 1. It cannot have value greater than 1. It cannot actually have negative value. So that's the type of collision, and more or less that completes the major theory part. To understand collision, I think to understand reformation and deformation, we can think of, okay, last one, one second. We can think of something like this. Suppose on a smooth surface, a block is kept here and the spring is placed here. And another block is moving with velocity v1. Of course, for it to collide, v1 has to be greater than v2 if they're moving in the same direction. See, just try and visualize what would happen when these two blocks get in contact. Moment they get in contact, spring starts exerting force. The spring will exert a force on the rear object in the backward direction and this object in the forward direction. And as long as this v1 starts slowing down and v1 starts increasing, let's just for the sake of some just understanding, suppose this was equal to 10 meters per second and this was equal to 5 meters per second. So we'll say just trying to, this is a good way to understand what happens in case of collision. So as soon as they get in touch, this starts slowing down and this starts increasing. But still, till such time, v1 is greater than v2. What will happen? The string will keep distance between m1 and m2 will keep on reducing till such time v1 is greater than v2. So what is the maximum compression? The maximum compression would be the case when velocity of two objects become equal. When velocity of two objects equal, so something like this, the spring is compressed. Afterwards, so maximum compression when velocity of the rear object becomes equal to velocity of the forward object, but still the spring is compressed. That's the maximum deformation of the spring. Afterwards, what happens after velocity become equal? The spring starts regaining its shape. How does it regain its shape? After compression, again start expanding. Because still after that, after the velocities have become equal, the spring is still applying a force in the forward direction of block A and rear direction of block B. So after the velocities have become equal, the velocities of A will start increasing further and B will keep slowing down further. So eventually what will happen when it regains its original shape, A object will end up having greater velocity than B object. So in this case, what has happened? There's a deformation. So when is the maximum deformation? Maximum deformation is when velocities are equal. Afterwards, reformation takes place. So when is the maximum potential energy stored in the spring maximum? Potential energy stored in the spring is maximum when velocities are equal. And afterwards, reformation takes place. Now again, potential starts decreasing. It starts getting transferred in form of kinetic energy. And if we look at in terms of what will happen, so a similar thing happens if you take a tennis ball. If you take a slow motion kind of picture, if two tennis balls strike, so when the tennis balls strike also, they will deform. So the distance between centers when they just get in touch is equal to sum of the radius. When they deform, the distance between centers will be less than the sum of the radius. Something similar to what is happening here. So in terms of force, let's see, what does T1 indicate? T1 indicates when the internal forces start acting, they get in touch. We are talking about collision between particles which do not have field forces. They don't have charge. So we are only taking contact forces. So this is the time we get in touch. And this time here, this is when the force is maximum. This is the condition of maximum deformation. And this is the case state when velocities are equal. And afterwards reformation takes place, and this is the time when they separate. So if I take, this is the time during which it was in contact. Force will not be constant during the time the collision takes place. This time period may be very small. Area under the curve indicates impulse. So if this figure, if force is positive, this might indicate impulse on A. Impulse on B will be similar in shape but opposite in direction. It will be negative impulse. So what is impulse? This impulse, area under force time curve, or I can say F dt. There's no need to write even vector form also. Straight away you could have write like this. If it is one dimension, F dt. So this is impulse which have acted. Both up, and if I have to draw impulse acting on other second particle will be exactly opposite of this. So that's what happens in case of collision. Fairly simple thing. Let's try and understand from this figure the concept of relative velocity of approach and velocity of separation. So when we talk of velocity of approach, suppose you can think of two objects as two different cars. If you are sitting in car A, when would the collision take place? Before collision, the car B will appear to be moving towards you. So if I see from A, this would be the velocity of approach, direction of velocity of approach. I am observing from where? I am observing from A. So before collision, car B, if you are looking from car A, car B will appear to be moving towards you. And after the collision, unless the cars stick together, I will see the car B moving away. So this is velocity of approach, and this would be the velocity of separation. And this is as seen from A. If I observe from B also A will be appear to be moving towards B. If we observe from B, again this would be velocity of approach. And from B, this would be velocity of separation, opposite direction. But most cases, when we think of solving a question, let's assume that we are observing velocity of approach from the object which is on the left hand side. So when we observe velocity of approach from object on the left hand side, velocity of approach will always be negative direction. It will always be towards left. It cannot be, if velocity of approach is other direction, collision will not take place. So this is a sign, and this is how the velocity of separation is. So let's take the head-on collision. So if this is the line joining centers, the velocities are in the same direction as the line joining their centers. If I join the centers, velocities are in the same direction. Let's take this velocity is v1 and this is v2. I can calculate velocity of approach. Just keep in mind, this would be equal to sum if u1 and u2 are in the opposite direction. In terms of magnitude, what will be relative velocity? It will be sum of the two velocity when they are in the opposite direction. It would be equal to difference if they are in the same direction. I can easily calculate, and I'll not bother about this is one dimensional question, plus minus sign is enough. So I can easily calculate velocity of approach. Magnitude, difference in the same direction, sum if opposite. And let's look at what is, how do I write this case here? If first object after collision, if I take the velocity as v1, I can write the velocity of the second object as v1 plus velocity of separation. So v1 plus, what is velocity of separation? Velocity of separation will be equal to v1 plus e into ua. So this negative sign, but this is the sign already taken care of. So whatever velocity of approach I calculate here, I multiply by e, that becomes velocity of separation. So I can write the second object will always have a velocity. So this is something from this object. The second object will always appear to be moving towards right. Okay, so I can write the velocity, and this is easy way to write. So if I assume this is v1, I can write as v1 plus e into ua, e being the coefficient of restriction. With everywhere we follow the sign, plus minus sign convention is enough. So once I write this equation, if e is given, I can find the value of only one unknown v1. I can find the value of v1 using conservation of linear momentum. Okay, and some cases we come across a case where one of the mass is much heavier than the other. Let's assume what happens if m2 is much heavier. So there's a truck going, I hit the truck with a tennis ball. What will happen to, and let's say all those things happening in one dimension only. So it's a gravity-free space. There's a spaceship. So what I do, I hit the spaceship with a tennis ball. So that also is a case of collision. In that case, what will happen? Whenever, if mass is one mass is much heavier than other, velocity of the object with much heavier mass will remain almost unchanged. So what is change in velocity if impulse is applied? If impulse J is there, J is equal to mass into change in velocity. If this mass is very large, change in velocity will be very small. That's what you're saying here. So let's take how do we convert in form of a equation. Let's see what will happen here. So if m2 is much smaller, if this initial velocity of second mass was u2, even v2 also will be equal to u2. This we can take as if it remains unchanged. So in that case, I can write, see, either I can say in two ways. Velocity of the second object is larger by e into ua, or I can say compared to second object, velocity of the first object is lower by velocity of separation. So if this is v2, I can write as v2 minus eua. v2 is nothing but u2. So that's a way we deal with one object being much heavier than other object. Rest conservation of momentum. Okay. Let's take a simple case. So suppose a ball of mass m is moving at velocity u. It has head-on collision with identical ball. Identical ball, this also mass m, and it's head-on collision. Head-on collision means, yes, if I join their centers, velocities along line they're joining the center, impulse also acts along the same line. So it's a one-dimension case. In one-dimension case, I can take this as positive, and I'll use all the values accordingly. So if I take this convention, what will the velocity? Okay, so that's what will the velocity of approach here, as seen from first one. Velocity of approach will be equal to minus u, as seen from the first object. Okay, velocity of approach will be u2 minus u1. So this velocity of approach negative, and hence velocity of separation will be equal to what? Velocity of separation is equal to minus e times ua, which is equal to e into u. That's what we use here. So if we write this, if we draw a figure, we can draw if this velocity, this object velocity is v, the velocity of the second object which is on the right hand side, will be v plus velocity of separation, v plus eu. So in this case, very easily you can find velocity. Suppose we have to find what is the fraction of energy retained and what fraction of energy is transferred if coefficient of restitution is e. It's fairly simple. It's more like simple derivation kind of thing. So we apply conservation of linear momentum. So what is the momentum before and what is the momentum after? And we are taking the sign convention right side direction positive. Mu will be equal to mv, momentum of the first object after collision, and second object has velocity v plus eu, momentum of the second object. So we can find value of v from this equation, which is the only unknown. The velocity of the first object will come equal to 1 minus e divided by 2 into u. Thus velocity of the first object. What will the velocity of second object? Plus eu. If I add plus eu, I get the velocity of the second object, which will be 1 plus e divided by 2 into u. So if we have to calculate what is the fraction of energy retained, fraction of energy retained is equal to final energy minus the, final energy divided by initial energy, which is u square v square by u square. I can easily find those values. Okay, u term gets cancelled out, v square by u square. So this term, and suppose I have to calculate fraction of energy transferred, it's also easy. It will come equal to 1 plus e square, 1 plus, it will become plus sign. So fraction of it. So any collision, once we have found out velocity, we can calculate terms like with this one. What is the percentage loss of energy? What is the fractional loss of energy? What is the energy retained by the first object? What fraction energy transfer? All such terms can be easily calculated. Once you have initial energies of two objects, once you have the final energy of two objects, all terms can be easily calculated. So let's come to another common example, ball falling onto a floor. Suppose I drop a ball from height h0 and coefficient of restitution is e. So in this case also, this case is a collision with a heavy object because floor is nothing but part of the earth. So this mass is much heavier. So this mass, if a floor was initially at rest, it will always, this will remain at rest. So this is the case, only one object moves, second object remains at rest. So in that case, what will happen? The velocity of the ball itself is velocity of approach, and velocity of ball after collision becomes the velocity of separation. So since floor does not move, the velocities of the ball before and after represent velocity of approach and velocity of lift floor, then this also will have motion. We see that later. So drop from my head. So what is the velocity? Let's assume that velocity just before it hits the floor, velocity is u, which itself becomes velocity of approach. And velocity of a ball after impact, let's say velocity of ball after impact has become v, and this becomes velocity of separation. How much will be velocity of separation? Velocity of separation in terms of magnitude, this will be equal to e into u. This is velocity of separation. Okay, now can we calculate this term height h1? If this was dropped from height h0, can h1 be calculated? Once we have these two velocities, h1 and h2 can easily be calculated. What is height of rebound? Can we calculate h1? All of you can easily do so. What is the height h1? h1 will be equal to v square by 2g. What is v equal to? E into u. E square into u square by 2g. What is u square by 2g? What is u square is equal to? U is equal to root 2g h0. So when we substitute, we can easily find the height of rebound is e square times h0. So if a coefficient of restitution is 0.5, so if a coefficient of restitution is 0.5, if I drop a ball from a height of 1 meter, what will be the height of rebound?
V1.
If I will drop a ball, Kevin, if I drop a ball from a height of 1 meter, I take a tennis ball, I drop from 1 meter. If coefficient of restitution is 0.5, what will the height of rebound of the ball after one collision, Kevin?
0.25.
0.25. It will jump up to 0.25. What will be the height after the second rebound? Again, e square times of the first one.
Yes, sir.
It will be e square of h1. So first time it has become h0 by 4, which become 0.25. So 0.2 by 4, 0.25 by 4, and so on and so forth. So this is something e square times h0. Suppose we have to calculate what is the loss of energy. It has not come back to the same height. It means it has lost energy. What is the fractional loss of energy? Fractional loss of energy. How do we calculate fractional loss of energy? It means the final energy is lesser than initial energy. When we calculate loss, loss is initial energy minus final energy, whatever term we use, and divide by initial energy. So what is the fractional loss? I can fractional loss, either I can calculate at this point or I can calculate this point. So what is the initial energy? mg h0. What is the final energy? mg h1. So very easily you can calculate fractional loss of energy also you can calculate. These are very simple calculations. Okay. Let's briefly look at something called oblique collision. Oblique collision, simplest example is a ball striking a floor at an angle. So let's say in this case, though it is shown like this, so just before the ball collides, its velocity is v, and it is making an angle theta with the common normal. So with the line of collision, actually this becomes my line of collision. Okay, it makes an angle theta with the normal. So suppose in this case also I have to find out, it strikes the surface at an angle theta with the normal, with the velocity v. What I'm interested, after it hits the floor and rebounds, what would be its velocity and what would be the direction of velocity? In terms of other way of saying, what will be the x and y component of velocity after it rebounds or after the impact? How would I calculate? That's a part of collision. And let's see, the calculation is very similar to what we have done here. What we are seeing here, it hits with velocity u, it rebounds with velocity eu. This also is very similar. Let's see how do we make it similar to the previous case. In this case also, line of collision will be vertical, normal to the smooth surface. Hence, impulse on the ball will be vertically upwards. I hope all are clear on this point. That's the line of collision. That's the line of collision, and impulse will act in this direction. If impulse acts in this direction, momentum and velocity only in the vertical direction will change. Horizontal direction, momentum as well as velocity will remain unchanged. So whatever is happening, actually collision is happening only along this line. So what we do, we resolve velocity into components. one along and other perpendicular to line of collision. So what are the components? Can we mark those collisions? What are the components along the line of collision? The vertical direction line of collision. So along the line of collision, the component becomes equal to u cos theta, and perpendicular to component becomes equal to u sin theta. Now, once we know and the coefficient of restitution is E, can you easily tell which part will change and which will not change? Grishma, can you tell me what will be the velocities after collision? Which velocity component will change and which will not change, and why? Grishma? Khyati?
Sir,
So after collision, this is the components of velocity. You tell me which one will change and which will not change and why. And the one which will change, what will its value after collision? Can you tell me, Khyati? No?
no,
You
sir.
understood what Padi is saying? Which direction the force is acting? Force is acting in the vertical direction. Impulse, you understand? Impulse also acting in the vertical direction. Would this impulse change momentum in the horizontal direction?
No, sir.
No, so which one is the horizontal direction? Which will not change? U sin theta will not change. Are you understanding why u sin theta will not change?
Yes,
Can
sir.
you tell me why this will not change?
Sir, because the force is acting in the vertically
Upward.
up.
No, so impulse is acting along line of collision. So components perpendicular to velocity will not change. So this will remain same. How about this velocity? This is u cos theta. What will be this value of coefficient of restitution is E? What will be the vertical component after collision, Khyati?
Sir, F minus U cos theta.
No, we just talked about coefficient of restitution. We have done something here. Previous case, what did we do just for a couple of minutes back? We did something like this. You recall what happened here? This was U. How much it has become after collision? EU. Why it has become EU? Because U becomes velocity of approach along the line of collision. And after collision, this is velocity of approach. Velocity of separation becomes E times the velocity of approach. So is there something similar happening here also? In place of U, what do we have here? Yes, Akash, you have something? Akash, you raise your hand. Any point?
No, sir. No, sir.
Okay. So this is U cos theta. Khyati, tell me, what will happen? What would be the velocity after collision? Okay. Kaushik? Kaushik,
Yes, sir.
can you tell me what will be the velocity after the collision? This is not changing. You understood why this will not change?
Yes, sir.
This will change. In this case, so I forget this part. So what we do whenever we deal with oblique collision, what we do, we forget about this part. This part is not going to change. It is equivalent to a ball striking the surface with the velocity u cos theta along the normal. So what is velocity? What is velocity approach? Velocity approach along the line of collision is u cos theta. Hence, after collision, it's like a one-dimensional collision with perpendicular component of velocity and momentum unaffected. This sentence, does it make sense, Kaushik?
Yes, sir.
Have you understood what does this statement say? So which one? This will not change. Now, if it doesn't change, I focus only in this part. If I focus only on this part, is it not like one-dimensional collision now?
Yes.
So in case of one-dimensional collision, just now we did, if velocity approach was u, if it hits the floor with velocity u, what velocity bounces back in the opposite direction? E into u. That's what was needed. Velocity components after collision will become like this. This will remain same u sin theta. It will become E times u cos theta. Was it difficult, Khyati?
No, sir.
You should have answered that. Okay.
Yes, sir.
So velocities, so what will happen? So what you have done, see, key point here is in case of oblique collision, this is important point. The component of velocity and momentum perpendicular to line of collision will not get affected. It remains same. So if we separate into two parts, one along the line of collision, one perpendicular to line of collision. The one which is perpendicular to line of collision will remain same anyway. So it becomes like a one-dimensional collision, head-on kind of collision. So what will happen when I focus only on this? It becomes like a one-dimensional collision. In place of u, now it is u cos theta. So velocity of rebound is E times velocity of approach. It becomes EU cos theta. So this is velocity of rebound. And can we find magnitude? Yes, magnitude there. So we can, this square plus this square is square root. Can we find out, see it hit the floor at an angle theta. Can we also find out what is the angle at which it will rebound? It's a theta dash. How much is theta dash? Can we calculate tangent of theta dash? So since we are measuring angle with the vertical, theta tangent of theta dash will be horizontal component by vertical component. Because I'm measuring angle from the vertical. When I measure angle from the horizontal, we take vertical first y component divided by x component. And of course, it makes sense. This is a tangent theta. If I extend this one, what is tangent theta? Tangent theta is this side, which is x component divided by y component. What is x component? U sine theta. Y component is EU cos theta. Sine theta by cos theta, tan theta by E. So this theta dash, will it be equal, greater, or less than theta? This is the equation. What I find here, this term on the right hand side, this term on the right hand side is greater than tan theta or less than tan theta?
Greater than theta.
Greater than tan theta. So theta dash also will be greater than, either equal, it will be equal when E is equal to 1. So if it is elastic collision, perfectly elastic collision, it will rebound at the same angle. But if it is not perfectly elastic collision, it will rebound at an angle greater than angle theta. So if I draw this one, so theta and theta dash, so suppose it strikes at some angle, say if it strikes at certain angle theta here, if it is elastic collision, it would have rebound like this along the same direction. But if it is not perfectly elastic collision, it will rebound something like this. This theta dash will be greater than this theta here. And what is the relationship? Tangent of theta dash is 1 by E into tan theta. Right. So just to understand this point, the difference between head-on collision and oblique collision, you can imagine, we can do that experiment also. What is shown here, suppose you have a table of height h. Okay, so plain smooth. A ball A, it rolls off the top of the table. So it rolls off, when it is from the edge, it is this is velocity v, height is h. At the same time, I drop another ball B, identical ball B. I drop this ball B from height h. I think some of you have your audio, I think, creating some disturbance. Let me check who's up there. Ashray. Okay, so let's me get back to that. So, okay, so yeah, have you understood what I'm saying here? One ball rolls off the table at time t is equal to 0. Another identical ball is released from the same height. So, when they go and collide, when we look at the motion, what can I say about their motion? At any instance of time, suppose it has hit the floor. This ball has moved like this. And there's some path, it will have a parabolic path. It hits the floor. Let's see, at any particular time, I find the ball is here. At time t, ball A is here. Can you figure out where the ball would be at the same instance? If I click a picture at time t, where would the ball B be at the same instance? Of course,
Same horizontal position.
Same horizontal position. Why would that be so?
The vertical acceleration
Both
is
have
same.
zero.
So the increase in the velocity is same.
So what happened? Exactly same thing. So when it is something, so what is happening in y direction is identical in both cases. So this also will hit. When it hits the floor, this ball will have, let's say this has velocity Vy. This will have some velocity Vx, but y component will be same. If y component is same, it rebounds with velocity Vy dash. This also will rebound with velocity Vy dash. So y component velocity will remain the same. So at any same instance, ball B dropped from the same height, they will be in the identical position. If you understand this, I think gives you a good intuitive understanding of what happens in case of oblique collision. So along the line of collision, nothing changes. See, this remains same. Along line of collision, similar thing keeps happening. All are clear about this point? Disha?
Yes, sir.
Are you clear?
Yes, sir.
So this is a simple thing, nothing very complicated, and I hope all have clearly understood. So these are the, I think, so we are done head-on collision. We looked at a special case. One mass is much heavier than the other. How to deal with that? Velocity of that object does not change. Then we also dealt with object falling on the floor. Object falling on the floor is equivalent to a case of one object being much heavier than the other. So in that case, the velocities of the ball before and after are velocity of approach and velocity of separation. We also looked at oblique collision. Because oblique collision also we can treat as a one-dimensional collision. If we resolve into velocities and momentum along the line of collision and perpendicular. That's all is there in case of collision. I think there's nothing more than this in case of collision in terms of basics understanding. And let's look at it. If both have same coefficient distribution, y coordinate always be equal. Okay, so let's apply this case what we understood. Let's apply in case of a projectile motion. See what will happen, just all of you, if you take a picture, you throw a ball onto the floor, it will have this kind of motion. So what does this line indicate? This is how a projectile may move, or if you project a ball from the surface, this is how the ball may move. Let's understand what these terms are. The oblique projectile. R indicates range, T indicates time of flight, H indicates maximum height. Okay, this is from the time of projection till the first impact. What will happen if it's a horizontal floor? If a coefficient of restitution is anything less than 1, it continues as a second projectile, and this is the second impact. So again, between first impact and second impact, again you will have a particular range R dash, and you will have height H dash, and again from here to here it takes time T dash. Can we write R dash, H dash and T dash in terms of R, H and T? And given that coefficient of restitution is E, can you all think of relationship between corresponding maximum height, corresponding range and corresponding time of flight? All of you think in your mind, and then I'll ask some of you to express relationship between two corresponding quantities in terms of coefficient of restitution. So all of you think for a minute how those two quantities will be, and this is based on what we had discussed in last whatever 10, 15, 20 minutes. Enough of thinking? All of you done your thinking? Okay, let's check with this. Anirudh. Anirudh Soma. Anirudh, that's. Anirudh, are you there or sleeping? Anirudh? One, okay. So enjoying his after result effect. After result effect, so Anirudh is missing. Okay. Kajal, can you tell me what are the corresponding values? Kajal, any clue?
No, sir.
No clue at all. Actually, very good. No clue at all. You're not able to think what will happen. Okay. Okay. So let me ask someone else then. Okay. Bhageshri, can you tell me what will be the corresponding quantity? What will happen after the collision? Bhageshri.
So the velocity will be changing.
Velocity will be changing, but what I'm asking, that's the intermediate point. What I'm asking, can you tell me, okay, let me make it a little simpler. This here it has risen to have maximum height H. Can you tell me what will be H dash, Bhageshri? Can you tell what is H dash? Okay, let me change the question, Bhageshri. Coefficient of restitution is E. If I drop a ball from height H, if coefficient of restitution is E, what is the height it will rebound to after one collision?
E square H.
E square H.
E square H. Will that be same here also? Will it be different?
Same.
Same.
Hey, Bhageshri, it is making sense or not?
Yes, sir.
So what happens when I'm looking at H, I'm looking at what is happening in the vertical direction. So when it hits the floor, is it not the same case? It is not exactly the case what we discussed here.
Yes,
Is it?
sir.
We apply the same concept. What will be H here? See, I can think of, let's say, if here it was equal to Ux, you can think of, start from here. And all of you, those other two also pay attention. This is Ux and this is Uy. When it hits here also, Ux and Uy will be there. What will the velocities after the impact? Can we tell what is the velocity? Ux will remain same. Which term will change? Y direction velocity. How much velocity in Y direction now after the impact? E times?
EUY.
So I can think H also, I can calculate H is equal to what? Square of velocity in Y direction divided by 2g. I can do that way, or I can also think here it is what is happening in Y direction. Y direction is something similar to ball being dropped from height H. So if this height was H, here the velocity in horizontal direction is 0, it has to be equal to E square H. I can do that, or I can also calculate H dash in terms of these terms. What is H equal to? H is equal to Uy square by 2g. This H dash will be equal to E into Uy square by 2g. So E square times H. I hope all of you follow. Kajal, have you understood this point?
Yes, sir.
Was it very complicated?
No, sir.
Okay, not very complicated. How about time of flight? Shreya,
Sir.
can you tell me this time of flight was T? In terms of E and T, what will this time of flight here? T dash. I have told H dash, how did you find the relationship? H dash is equal to E square H. Can you similar way tell me what is T dash equal to? You have to recall something about projectile motion.
Yes, sir.
What is time of flight equal to? Among the two, which velocity component the time of flight depends on? X component or Y component? Shreya.
Y component.
Y component. What is the time of flight? Can you tell me in terms of Uy?
U square, sir.
Nothing, remember. Time of flight is 2 Uy
2
by G.
UY by G.
Yes. So time of flight is proportional to velocity in the Y direction. If velocity becomes E times, the time of flight also becomes E times. So what is time of flight? Time of flight is 2 into Uy by G. If so, it means what I noticed, time of flight is proportional to Uy. Maximum height is proportional to square of the velocity in Y direction. That's why this has become E square. What will T dash?
ED.
E.
How about range?
The
How about
UX
range?
remains
Tejas, can
constant.
you tell me about range? Can you tell me relationship between R and R dash now?
Yes, sir.
Yeah.
Range depends on the horizontal component, right, sir?
Very good. It depends
So
on horizontal component and something else also.
Time also.
So what is range? I could have written range
E
as
times R.
what? Range as
2ux into uy by g.
I can write range as this also. Is it not? That's range. So what has happened here? Can I write R dash now? What is R dash
Yes,
now?
sir.
How much R
UX
dash will
remains
be?
unchanged and
UX
T
into
begins
ET.
with
US into ET. So
Yes.
it will be E times
E
R.
times R. Yeah. Yes, sir.
So is it something, see, you can deduct all those things, but I think it's much easier if you understand the concept of collision. Very easily we can deduct this quantities. That's what is happen in case of projectile. And then we can have multiple question projectile. If you understand this one, I think you have understood basics of oblique collision as applied to projectile motion. And then we can have multiple combination. We had done last time questions, what happens if you have vertical wall here? What happens if you have vertical wall here? Those kind of question also you can practice, but these are basic essentials of collision. I think most part we have covered. Only thing what I have not done, I have not done oblique collision for two spherical object, which is not necessary at this stage. Anybody has any problem so far? All have understood? Anybody who is not clear? So we can quickly go back and check. So far, everyone finds easy what you have done about collision. Collision, only thing new what you have defined, collision is conservation of moment. Line of collision we have defined. And if it is head-on collision, is one-dimensional motion, plus minus sign is adequate. And two objects we take as a system, momentum always remains conserved. Energy may or may not get conserved. Energy remains conserved only in case of perfectly elastic collision, other cases it is not conserved. What else we have done in case of this? The only thing what we have done, mostly I have used the concept of coefficient of restitution. velocity of separation is E times velocity of approach in the opposite direction. Of course, the direction has to reverse. So when is velocity of approach, I'm looking for a rear object. Initially, the car in the front will appear to coming towards you, and after collision, it will appear going away from you. Using that concept, I can express the velocity of the second object as v1 plus E into velocity of approach. And then we can solve those questions. And then we take an oblique collision. Oblique collision also can be treated as equivalent to a one-dimensional collision. What we do in that case, we resolve into two components, components perpendicular, component along the line of collision. Component perpendicular, just as it is, we put it in the final state. Along the line of collision, it becomes one-dimensional collision. The principle can be applied. That's a typical example of a projectile. Okay. What is left now? After this, now we'll solve questions which are based on what we have discussed so far. So we'll do, I think, a few questions now, and we'll do some more question in the work session in the afternoon. Okay, after impact, X component same, Y component E times. Okay, this is a pretty simple result what we have. Okay, let's start with, we'll start with some very, very simple questions, and all questions I expect all of you to solve. And I will, again, I'll ask some of you to answer. So only those whom I ask should answer. So read question one by one and answer. Prepare an answer in your mind. If not, least what I expect, you should tell me the method to solve at least. All are less than a minute question. Nishita. Nishita?
Yes, sir.
462 girl, huh? 462, huh?
Yes, sir.
Oh, very good. So can you tell me what is the answer for this? How do you solve this question? Nice. Have you done something like this? Nishita, tell me, this is if I drop a ball, from what height? Suppose I drop from height h. If coefficient of restitution is E, what is the height of rebound, Nishita?
E square H.
E square h. Is it not the same question?
Yes, sir.
So what is h is given here? So this is the height of rebound. So height of rebound is, this question is pretty simple. Height of rebound is equal to E square. E square times h naught. Okay, so this is the, oh, sorry, but what I'm doing E square. So this is one part. What we have to calculate, what fraction of energy is lost? Can you calculate what is fraction of energy lost, Nishita? So it is dropped from height of 2 meters. Okay, and I'm doing something else. So this is something, it rebounds to height of 1.5 meter. Can you calculate loss of energy, Nishita, anywhere here? If the loss is taking place, see the motion is like this. It falls from here to here. And then it is actually same point where you're drawing like this. It goes back like this. So where exactly is the loss taking place during its motion? Loss is taking place only at this point, during the impact. That's where the loss takes place. So can you identify what is the, how do you calculate initial energy and how do you calculate loss of energy? Nishita? Can I take, see from here to here, anywhere energy is constant. Can I take this energy as initial energy and this point as final energy? So anywhere in this way, so I could have taken, see when and it's falling, we have done conservation of mechanical energy. So whatever energy I take this point energy will be same as this point. So actually loss of energy, what I need to calculate, loss of energy is, I need to calculate what was the energy of the ball just before the impact and what is the energy of the ball just after the impact. But energy just before the impact is same as the energy here. And energy just after the impact is same as the energy at this point. Is this point understood? Shravani, have you followed what I'm saying?
Yes, sir.
So can you tell me what is the energy at this point? Does it have kinetic energy at this point when you drop the ball? At this point, does it have any kinetic energy? No, it only has potential energy. What is the potential energy? If I write initial energy, I hope you have understood. Initially, this is what is needed. This is this point correspond to final energy. This correspond to initial energy. Initial energy is mgh initial, which is 2 meter, and final energy is equal to mg into 1.5. So what when we talk about loss, because when we talk about loss, final value is less than initial one. Initial minus final divided by initial energy. How much is that equal to? 2 minus 1.5 divided by 2. And this is something you should have done very quickly. Shweta? Shweta, are you there or Professor? Many people are very silent today. So I think they're still celebrating, but there's something, they're still in the mood of celebration. Shweta, are you there? No. Samita?
Yes, sir.
Have you been listening?
Yes, sir.
Have you understood this point?
Yes, sir.
Where does the loss of energy takes place? It falls, hits the floor, rebounds. Where is the loss taking place? Which point of motion is the loss taking place? You have not been listening carefully, Samita. You need to be more attentive. So next time onwards, be a little more attentive. And Kartikeya, are you clear?
Yes, sir.
Kartikeya, huh?
Yes, sir.
Let us do next question. Gayatri,
Yes, sir.
can you solve this question?
Yes, sir.
Tell me, how would you solve?
Sir,
Hmm?
sir, it is
Okay. Okay, let me tell Gayatri, and this is something I think every time, every question, I expect you people to tell me the method how to solve. See, let me think. See how what is said, what is given. See, words, whatever information given in words, those things we need to convert into equation. Two masses stick together. What does stick together means? If velocities after the collision is v1 and v2, both are equal. That's what stick together mean. So what will happen? Both of them will have a common velocity equal to v. So it is something like this. If this is 20 kg object, the first point is sticking together means both will have common velocity. Question is, how do I find common velocity? I can find common velocity using which principle do I need to apply to find common velocity here, Gayatri? Let's say this is 20 kg mass and is moving at the speed of 10 meters per second. I think I've made the figure also. No. Okay, it's moving at 10 meters per second. Another stationary mass, 5 kg mass. This is at rest. And finally, when they stick together, it will become equal to 25 kg and it has velocity v. That's what is happening. So how do you find v? There's only one mass, so there's only one velocity. How do I find this value of v, Gayatri?
M1 V1 plus M2 V2 is equals to.
Correct. So first thing I
M1 V1
calculate
also.
conservation of linear momentum, which is the basic principle used everywhere. So conservation of linear momentum, 20 into 10, both are in the same direction, is equal to 25 into v. So what is v?
Eight.
8 meters. So can I calculate what is the kinetic energy of the composite mass? Then I calculate
Yes,
kinetic.
sir.
So what you have to think now, okay, moment stick together means, okay, any collision, this is a figure you should come to your mind. Any collision is like this. In any collision, what we should think on our mind, there is a state, these two objects moving before collision. There are objects after collision. If they are not in the common velocity, v1 and v2. In this case, this is what both will have common velocity, means v1 is equal to v2 is equal to v. I can find out v using conservation of linear momentum. Once I have found the velocity, I can find out kinetic energy. That's what I expect you to respond, Gayatri, and rest of you also. This question, these are simpler ones. And this question you can do in your mind. They are as simple, so simple as. What is the total distance covered by the ball before second hit? Anish,
Yes, sir.
can you answer this question?
Yes, sir.
Tell me how would you answer?
First, it covers a height h.
Huh?
Then
Okay.
after the collision, it covers the distance e square h.
Okay, good. So what you are saying, it will fall from height h. It will rebound to certain height.
Yes.
What is the height it will rebound to?
E square h.
E square h. So this is something first impact, and this is the second impact. What is the distance it has traveled? Distance traveled is this distance plus this distance plus this distance. How much is the total distance?
H into 1 plus 2 e square.
Perfect. This is an easy question. You could have done very easily within few seconds. Very good. Let's look at this question. Next one. Okay, so this is based on, I think I have not mentioned, this is special property. When two equal masses have perfectly elastic collision, their velocities interchange. Elastic collision between two equal masses, velocities interchange. So whatever velocity A had before collision, B will have the same velocity in magnitude as well as direction. And whatever velocity B had before collision, A will have after collision. So this is based on that concept here. So can we answer this question here? What will happen? So it is like a pendulum. So one ball comes and hits B. What will happen soon after that? Where is the collision happening? This is something, is it like a 1D collision or is it a circular motion? So as far as the collision goes, we need to only focus at the time just before collision. Just before collision, velocity of A will be in the horizontal direction. It would be just like a 1D collision. So just before collision, it will appear something like this. If this is B here, and B is at rest, and A is having velocity perpendicular to the string in the horizontal direction. What is the velocity A will have? Let's say it has velocity VA, or let's say UA. What will happen soon after collision? This is before. And what is the situation after? The velocity will interchange. What does velocity of interchange mean? B will have a velocity equal to UA. And what is the velocity A will have? Since B was at rest, A will come at rest. Now B will acquire a velocity which is same as UA. And since the masses are equal, if UA has, this has acquired a velocity by having a vertical displacement h, even B also will reach a point which has same height. Hence, it will reach the same angle. That will be the final state. B also reach the height h as A. So what is the answer? So B also will rise to the same height because this also acquires the same velocity with mass being equal, and A will come to a rest. This is based on this principle. So that's what it is, and we'll continue with some more question in the evening session so that we get more or less we completely revise this small topic. So I'll end the session here. Those who have any other query or question can ask that one, and the rest of the people can sign off now. Okay, thank you. Yes.
Sir, when oblique collision happened with the ground, the impulse is due to the normal force, right?
Yes. What every time, what is the assumption we are making? We are making assumption the surface is smooth.
Yes, sir.
So surface smooth. Can you apply a force which has a tangential component?
If there was friction, then there'll be
Friction becomes
force in the
complicated. Then it will
X
happen. But 99% cases, very rare cases, there are very few examples of friction force coming into picture. Yes, some cases friction force will happen. I'll give an example if you want to understand that one. I'll give a small example also of how does friction act. Maybe evening session I'll tell you.
Like if we throw a ball, it can cause a spin, right?
Yes. So just try two things. What are two things we can try?